Hello everyone and welcome to St. Andrew's Institute of Technology and Management, Gurgaon, Delhi NCR. St. Andrew's Institute of Technology and Management is the best college in Delhi NCR, in northern India, in entire India. In fact, it is the upmost coming college keeping in mind all the latest development in terms of education, research and placement. St. Andrew's Institute of Technology and Management offers you a wide variety of courses from BTech, BCA to BBA, and also starting with MBA and law, architecture too. So this is the upmost, utmost, and the most prestigious college to be. This will be the best choice that you can make for yourself or for your children. They provide 100% placements, right? The subject that we should be covering in this video is Principles of Software Engineering. The code is CSE 302F. It is a CSE 6 semester subject in accordance with MDU University Rohtak F scheme syllabus. The topic we'll be taking here are software project management, concepts, process and project matrices. I, Shalini, from CSE department shall be taking you forward. Software project management. A software project is the complete procedure of software development from requirement gathering to testing and maintenance, carried out according to the execution methodologies in a specified period of time to achieve intended software product. Like we discussed in our previous lectures also of software lifecycle models, we discuss all the stages of software development, requirement analysis, gathering, then deployment, then implementation, testing, maintenance, etc. Right? So all this comes in the software project. Software project management refers to the branch of project management dedicated to the planning, scheduling, resource allocation, execution, tracking and delivery of software and web projects, right? So it is an essential part of software organization to deliver all the three. What are they? Quality product, keeping the cost within client's budget, and deliver the project as per schedule, right? So a good software project management should encompass all the three. The time should take into account time, the cost and quality of the product. Okay. Next we come to a project manager. A project manager closely monitors the development process, prepares and executes various plans, arranges necessary and adequate resources, maintains communication among all team members in order to address issues of cost, budget, resource, time, quality and customer satisfaction. So all these things will be done by a project management manager. If anything goes wrong, the project manager will be responsible for it. So he has to take care of everything, his team members also, the customer satisfaction also, and all the technologies that are being coming into use, that are being put for the development of the software, to everything that goes on from cost, budget, everything has to be taken care of by the project manager. So we can see here a few responsibility of him. So it we categorize into two. The first is managing people and the second is managing project. Okay. So in managing people, the software project manager, he has to act as a project leader. He has to liaison with the stakeholders. He has to manage the HRs and he has to set up remote reporting hierarchies also. Right? While managing project, he need to define and set up project scope, managing project management activities, monitoring progress and performance, risk analysis at every phase, take necessary steps to avoid or come out of problems, and act as the project spokesperson. Next, we come to software management activities. Software project management comprises of a number of activities which contains planning of project, deciding scope of software product, estimation of cost in various terms, scheduling of tasks and events, and resource management. The project management activities are basically included as three. The first is the project planning, the second is the scope management, the third is the project estimation. We'll see all of the three one by one. Project planning. Software project planning is the task which is performed before the production of software actually start. It is therefore for the software production but involves no concrete activity that has any direct connection with software production. Rather, it is a set of multiple processes which facilitate software production. So planning has to be done before the actual software start, and this we can see practically also. Whatever work we have to do, we first plan it before the actual work start. So project planning is always done before. Next we come to scope management. It defines the scope of the project. This includes all the activities the process need to be done in order to make a deliverable software product. Scope management is essential because it creates boundaries of the project by clearly defining what would be done in the project and what would not be done. This makes project to contain limited and quantifiable tasks which can easily be documented and turn avoid cost and time overrun. Right, so this is very important. Why? Because it would prioritize the task also. It would have quantifiable task and limited as it would define the boundaries also. So right, so during process scope management, it is necessary to define the scope, decide its verification and control, divide the project into various smaller parts for ease of management, verify the scope, control the scope by incorporating changes to the scope. Project estimation. For an effective management, accurate estimation of various measures is a must. With correct estimation, managers can manage and control the project more efficiently and effectively. Right? So, this is very necessary also, and it involves various things. What are they? The very first is the software size estimation. The software size may be estimated either in terms of kilo. What is kilo? That is kilo line. Of course, how many thousands of lines of codes are there? So this is one way of actually estimating the size. And the other is by calculating the number of functional points. The line of code depends upon coding practices, and functional points vary according to the user or the software requirement. Why? Because functional points are always put by the user. They're defined by the coder, or the one who's actually writing the code for who's making the software, I would say. Right? So both of these techniques can be taken into account. Kilo line of codes also, and number of functional points also. So both K-log and functional points which actually give me an estimate of the size of the software. Okay, next we come to effort estimations. The managers estimate efforts in terms of personal requirement, and non-man are required to produce the software. For effort estimation, software size should be known. This can either be derived by manager's experience, organization historical data, or software size can be converted into efforts by using some standard formulae. Right? So manager would actually keep a track of how many personnel that he required to employ for the making of this particular software. How many man hours are required to produce? Okay, and then he will be dividing and seeing he'll making a TL or the various sub leaders, or he'll do an effort estimation. Right? Next is time estimation. Once size and efforts are estimated, the time required to produce the software can be estimated. Efforts required is segregated into subcategories as per the requirement specifications and interdependency of various components of software. Software tasks are divided into smaller tasks activities or events by work breakthrough structure, that is WBS. The tasks are scheduled on day-to-day basis or in calendar months. Right? So time has to be a very crucial factor, because you have to tell the customer also as to at what time you will finally be deploying the product to him, and at what time he'll be able to actually see it. So this is very important. Next we come to, okay, and there's one point to note also in this: the sum of time required to complete all tasks in hours or days is the total time invested to complete the project, right? Okay, the next factor is the cost estimation. This might be considered as the most difficult of all because it depends on more elements than any of the previous ones. For estimating project cost, it is required to consider size of software, software quality, hardware, additional software or tools, licenses, etc., skilled personnel with task specific skills, the travel involved, communication, training, and support. So, all this are the things that account for the cost estimation. Okay. Now, project managers have a wide variety of matrices to choose from, right? So, we classify them into various groups. And what are they? This is the process matrix, the project matrix, the product matrix, organizational matrix, software development matrix is example. Okay, so we see one by one. First is process metrics. These are matrices that pertain to process quality. They are used to measure the efficiency and effectiveness of various processes. Next we come to project matrices. These are matrices that relate to project quality. They are used to quantify defects, cost, schedule, productivity, and estimation of various project resources and deliverables. Next, we come to product matrices. These are matrices that pertain to product quality. They are used to measure cost, quality, and the product's time to market. Next, we come to organizational metrics. These matrices measure the impact of organizational economics, employee satisfaction, communication, and organizational growth factors of the project. Next is software development matrices. These matrices enable management to understand the quality of the software, the productivity of the development team, code, complexity, customer satisfaction, agile process, and operational matrices. The two most important categories are project matrices and process matrices. First, we see project matrices. Okay, the very first matrix that amounts is the schedule variance. See, any difference between the scheduled completion of an activity and the actual completion is known as schedule variance, right? So whatever that has to be, that was the one that actually was the time for completion of activity, and what it was scheduled to be, right? Say suppose you say that it will be completed into 4 months, and then it took 5 months. So the difference between the two is the schedule variance, right? So schedule variance, what's the formula, is equal to actual calendar days minus planned calendar days, right? So actually how many days it took and how many were planned actually, plus start variance divided by my planned calendar days into 100. Effort variance, difference between planned outline effort and the effort required to actually undertake the task is called effort variance. Effort variance is equal to actual effort minus planned effort divided by planned effort into 100. Okay. Next is size variance, difference between the estimated size of the project and the actual size of the project, normally in kilog and FP. So size variance is equal to actual size minus estimated size divided by estimated size into 100. Requirement Stability Index. This provides visibility to the magnitude and impact of requirements changes. Requirement Stability Index is equal to 1 minus this entire thing. And what is this entire thing? Number of changed plus number of deleted plus number of added upon total number of initial requirement into 100. Right, so all this adding the changed, deleted and added requirement divided by the total number of initial requirements into 100, and all this is I would say subtracted from 1. So this gives the requirement stability index. Next is productivity of the project. It is a measure of output from a related process for a unit of input. Right, so project productivity is equal to actual project size divided by actual effort expanded in the project. Next we come to productivity of test case preparation. This is actual number of test cases divided by actual effort expanded in test case preparation. Productivity for test case execution. Actual number of test cases divided by actual effort expended in testing. Okay, the productivity of defect detection. Actual number of defects, that is review plus testing, both divided by actual effort spent on review plus testing. Right. Next is productivity of defect fixation. This is equal to actual number of defect fixed divided by actual number of spent on defect fixation. Schedule variance for a phase. The deviation between planned and actual schedules for the phases within a project. Schedule variation for a phase. Actual calendar days for a phase minus planned calendar days for a phase plus start variance for a phase divided by planned calendar days for a phase into 100. What is effort variance for a phase? The deviation between a planned and actual effort for various phases within the project. So effort variance of a phase is equal to the actual effort of a phase minus a planned effort for a phase divided by planned effort for a phase and 100. See, you will all remember this formula as in when you practice. Okay, you can't, I don't expect you to mug up in one single go, but like this is by time you learn all these things. Next we come to process matrices. The first matrix of process is cost of quality. It is a measure of the performance of quality initiatives in an organization. It's expressed in monetary terms. Cost of quality is equal to review plus testing plus verification review plus verification testing plus quality assurance plus configuration management plus measurement plus training plus rework review plus rework testing divided by total effort into 100. Right? So all these factors will give you the cost of quality. The cost of poor quality. It is the cost of implementing imperfect process and product. Right? And what is it? This is equal to rework effort divided by total effort into 100. Next we come to defect density. It is the number of defects detected in the software during development divided by the size of the software, typically in KLOC or FP. Defect density for a project is equal to total number of defects divided by project size in KLOC or FP. Review efficiency. This is defined as the efficiency in harnessing divided by detecting review defects in the verification stage. Review efficiency is equal to number of defects caught in the review divided by the total number of defects caught, right, into 100. Testing efficiency is equal to 1 minus defect found in acceptance divided by the total number of testing defects into 100. Defect removal efficiency is given by this quantifies the efficiency with which defects were detected and prevented from reaching the customer. So defect removal efficiency is equal to 1 minus total defects caught by customer divided by total number of defects into 100. Residual defect density is given by total number of defects found by a customer divided by total number of defects including customer found defect divided by multiply by 100. Right. The few important questions are: what is software project management? What are the role and responsibility of software project manager? What are software management activities? What are different matrices used by project manager? And explain the process and project matrices. I hope it is clear to you. Thank you.